Welcome to The Explainer. Today, we're going to tackle a classic coding challenge that honestly has a surprisingly elegant and clever solution. And it all kicks off with a simple question about a landslide election.
So picture this, it's election night. Votes are just pouring in. It's a total landslide. One candidate has clearly captured more than half of all the votes. Now here's the puzzle. How could you figure out who that winner is with 100% certainty just by looking at the votes one by one, without needing some giant spreadsheet to keep track of every single candidate?
Well, the secret is actually super simple. If a candidate has a real majority, we're talking more than 50%, that means they have more votes than all of their opponents put together. So think about it. If you pair up one vote for the winner with one vote for an opponent, poof, they cancel each other out. And since the winner started with more votes, they're guaranteed to have some left over when all the dust settles.
That whole election idea, it's the perfect way to wrap our heads around the coding problem we're about to solve. So let's see how this concept of a landslide victory translates from politics into the world of arrays and code.
In programming, we call this the majority element problem. We're given an array of numbers, and our job is to find the one number that shows up more than half the time. So the numbers are our votes, and that majority element, that's our landslide winner. And here's a key detail for this problem. We are always guaranteed that a majority element exists.
Okay, let's look at a couple of quick examples to see what we're talking about. In this first array, 3, 2, 3, there are 3 elements. Half of that is 1.5. The number 3 appears twice, so yep, it's our majority element. In the second, bigger array, you can see the number 2 appears 4 times out of 7 total elements. That's definitely more than half, making it the clear winner.
So how do we find this winner efficiently? We need a smarter way to count. And this is where things get really cool. We're going to use a brilliant method called the Boyer-Moore voting algorithm.
You know, the first thing you'd probably think of is using something like a hash map to keep a running count of every number. And that's basically our giant tally sheet we wanted to avoid. It works, sure, but it uses extra memory. The smart way, the Boyer-Moore way, finds the winner without that tally sheet, using almost no extra memory at all.
Okay, here it is. This is the aha moment of the entire algorithm. Just think of it exactly like a vote cancellation system. We'll pick a potential winner, and every time we see an opposing vote, one of our candidates' votes gets canceled out. It's a simple one-for-one trade. The logic here is incredibly simple. We only need to track 2 things: a candidate and their current count. As we go through the array, we follow one key rule. If our count ever drops to 0, the current candidate is out. The very next number we see becomes our new candidate. Then, for every number after that, we just ask, is it a vote for our candidate? If yes, count goes up. Is it a vote against them? Count goes down. That's it. After we've gone through all the numbers, the candidate left standing is our winner. Okay, that's the theory. But let's actually walk through it. We're going to take that second example and watch this algorithm work its magic, step by step.
All right, here we go. Our array is 2, 2, 1, 1, 1, 2, 2. First up, the number 2. It becomes our candidate, and its count is 1. Easy. Next number is also a 2. Great, that's another vote for our candidate. The count goes up to 2. But now we hit a 1. That's an opposing vote, so we cancel one vote for 2, the count drops back to 1. We see another 1, we cancel another vote. And look at that, our count is now 0. Since the count is 0, candidate 2 is out for now. The next number we see, which is this 1, becomes the new candidate with a count of 1. But its reign is short-lived. The very next number, a 2, immediately cancels its vote, and the count goes right back to 0 again. And finally, with the count at 0, the last number, 2, becomes our new candidate. And that's where we end up.
And just like that, we're at the end of the array. The final candidate left standing is 2. And that's our answer. Because the true majority element has more votes than all others combined, its votes can never be fully canceled out by the end. It is mathematically guaranteed to be the one left holding the title. Now, what's so amazing about this is how this elegant logic translates into just a few lines of incredibly clean and efficient code. Let's pull up the Java implementation. You can see the code is a direct translation of what we just did. It only needs 2 variables, one to hold the current candidate and one for the count. The whole thing happens in one single loop. And that line right there, if count equals 0, that's the most important part.
That's the mechanism that lets us switch to a new candidate whenever the old one's support is completely canceled out. It's a perfect match to our analogy.
So why is this algorithm so fantastic? It's all about performance. The time it takes is what we call linear, or O of n, which is just a fancy way of saying we only have to look through the array once. But the real showstopper is the space usage. It's constant, or O of 1. This means it doesn't matter if the array has 10 numbers or 10 million, we only ever need those two little variables. No extra tally sheet necessary.
So, we've seen how this powerful idea of cancellation can elegantly solve our problem. It really makes you wonder, doesn't it? Where else in the world of problems could this strategy of pairing up and canceling out opposites be the key to simplifying something that seems complex? It's a powerful pattern to keep in your mental toolkit. Thanks for joining us on The Explainer.